Artificial photosynthesis mimics this process that happens in nature. Instead of sunlight shining on a leaf as it does in nature, researchers use structures made of intricately manufactured semiconductors. In other words, an artificial leaf. And with it, solar energy can turn water into hydrogen and oxygen. The efficiency of artificial photosynthesis is currently at 19.3% and was jointly achieved by laboratories in Pasadena, Ilmenau, and the Fraunhofer Institute. If this process could be scaled up for industrial use, hydrogen would become cheaper than any other fuel. That's why research into artificial photosynthesis is being conducted worldwide.
We're now talking about the application of such semiconductor structures in a so-called artificial place, meaning an integrated device that does not need any wiring to the outside, similar to plants, so that we can basically produce hydrogen and oxygen more or less from nothing, just through sunlight and water.
Wasserstoff und Sauerstoff erzeugen aus Wasser.
Now, for the first time, we're in a position where we can essentially provide free energy using photovoltaics, the same way nature has been doing for a very, very, very long time. And this has never been possible before.
So wie es praktisch in der Historie noch nie möglich gewesen ist.
It's hard to overstate the significance of semiconductors. They're small and inconspicuous, but they are the basis of all advanced technologies and can be made of many different types of materials. Researchers at the Technical University of Ilmenau work with so-called 3-5 semiconductors.
3-5 Halbleiterverbindungen.
3-5 semiconductor compounds are the ones we can design perfectly.
Das mit Silizium.
Using silicon as the base material, that would of course be very profitable.
Praktisch Basismaterial.
That's where high performance would meet cheap materials and low costs.
Da hätte man hohe Performance gekoppelt mit günstigen Materialien, günstigen Kosten.
Of course, not every single part of these new energy systems is ready for action, but rolling out innovation to communities and industry will be key. There are still many scientific breakthroughs and technological innovations that have not yet been widely implemented for public use.
If we go